is for Year 11 methods. We're going to look at exercise 3K, question 15. So a family of parabolas satisfies this rule, okay? And you want to express that rule in turning point form, okay? So let's bite the bullet and actually do it. I want to take the factor of a out first because we've got a in front of the x squared. You cannot use a scaffold or complete the square if there's a number in front of the x squared. So come 2 over ax plus 1. I want to use a scaffold inside now. So that'll be x plus 1 over a. Half of 2 over a is 1 over a. 1 over a squared is 1 on a squared plus 1. Okay. So I want to re-expand the bracket. Okay. So this will become a x plus 1 over a squared. And I'm multiplying a by this whole thing. Okay. So I'm multiplying a by negative like this. So what you'll get is a on a squared, which is, or a on negative a squared, which gives you negative 1 over a. And when I multiply 1 by a, I get a. Okay, so I can rewrite that as plus a minus 1 over a. Okay, I've just switched the order around. That's okay. So my TP would be given by opposite what you expect inside bracket. So that's an a there, negative 1 over a minus 1 over a. Okay. So next step is so we've done step A and step B. We found the turning point coordinates. For what values of that equation is a perfect square? Now it's a perfect square if this thing's gone. Okay, that thing is 0 because we're left with a perfect square. Okay, so in order for it to be perfect square, we let a minus 1 on a equals 0 and solve for a. Okay, so I can multiply both sides by a. So when I multiply both, I get a squared. That gets rid of the a here, because when you multiply and divide by a, that goes poof, gone. You're left with a negative 1. A squared equals 1. A must be equal plus or minus 1, and that's your solution. Now, part D, for values of a, does the graph have 2 axis intercepts? Okay, 2 axis intercepts, that should give you an inkling to use the discriminant. Okay, so 2 axis intercept means discriminant is greater than 0. So discriminant, I'll do it over here. Discriminant is given by b squared minus 4ac. So my b value is 2. 2 squared is 4 minus 4 times a, which is a, and c happens to be a as well, which is a bit weird, but that's how the question is. Minus 4a squared. We want that to be greater than 0. Okay, so I want to get a visual of what that looks like on the graph. 4 minus 4a squared. I'm better off factorizing that. We've got 4, 1 minus a squared equals is greater than 0. So we need to get an idea what the discriminant graph looks like. And we know that 1 minus a squared is a dot, so 1 minus a, 1 plus a is greater than 0. So we've got a graph that's going to be a frown because there's a negative in front of the a. So we've got discriminant versus a. We've got a frown and we've got intercepts at negative 1 and 1. Got a frown. When is the graph greater than 0? Or when's the discriminant greater than 0? It's between here and here, so it's up there. So a would be but greater than negative 1, but less than 1. Okay, and that should give you your final answer. Now, if you were to do it on the CAS, you can, especially for the discriminant. You can go get expression for discriminant. So 4 minus 4. I'm not going to use a. I'm going to use x just for convenience. Is greater than 0. I'm going to go interactive, advanced, solve for a essentially, and you can see I get the same answer. But in order to do it by hand, you need to visualize what that graph actually looks like, which I've done there. I've just factorized it just so I can see where the a-intercepts are, or my x-intercepts are, so I can get which region I want the graph. When it's a frown, and when I want it to be greater than 0, so it has to be up here. That's when the screen happens to be greater than 0. So hopefully that helps.